Hi everyone, my name is Faizan. I'm the co-founder of Headstarter, and this is going to be an overview of the second AI project in the Headstarter Accelerator program. For this project, we're going to be building deep learning models to classify which type of tumor is present in a brain MRI scan. Being able to identify and differentiate between various brain tumors in an MRI scan can be challenging even for neurologists and neurosurgeons because these tumors vary a lot in appearance and they share characteristics with other brain conditions such as inflections or inflammation, which can make accurate classification of these MRI scans very challenging. So this type of task is perfect for neural networks because they can be trained specifically to differentiate between various tumors and identify abnormalities that can be easily missed by human eyes. With neural networks, the process of analyzing large volumes of MRI scans can also be significantly sped up, and it can reduce the variability in interpretations that might occur between different neurologists or at different times. So in this project, we'll train multiple neural networks on a dataset of 1,000 brain MRI scans, where each MRI scan can be classified as containing either a glaucoma, meningioma, or pituitary tumor, or not having a tumor at all. After training and evaluating the neural networks, we'll be building this web app you see here, where a user can upload an image of a brain MRI scan, and then using the trained neural network we built, it classifies which type of tumor is present in the MRI scan and to what degree of confidence. So for this particular brain tumor, the model predicted that it has meningioma with a confidence of 99.99%, and we also display a saliency map of the brain MRI scan, which highlights the areas of the image that have the most influence on the model's output. So we can see the most important areas of the image are highlighted here. And so with context of the model's prediction and the saliency map, we can use a multimodal large language model such as Gemini 1.5 Flash to generate an explanation of the model's prediction and explain which area of the brain is of highest importance. So we can see here the saliency map shows a well-defined round mass in the right parietal lobe, which is a common location for meningiomas. So the model is focusing on the surrounding edema, which is a characteristic of these tumors. So this would help a lot to a neurologist or a neurosurgeon so they can cross-reference this with their own expertise and knowledge and focus on these specific areas when reviewing the MRI. Now, in this project, we'll be training two neural networks, one using transfer learning, where we use an existing deep neural network with assigned weights as our base model, and the second one being a custom convolutional neural network that we construct ourselves. And the point of this is that so you can see the difference in and variability in the model predictions and how the classification might change. So with the custom convolutional neural network model that we built, you can see that the saliency map is a bit different than the transfer learning model, and the confidence in prediction is a bit lower. So this will help you understand the differences between the different model architectures and also the differences in training them as well. And we can see here the explanation is a bit different for this model as well. Now I also want to show how the model classifies brain MRI scans that have different tumors in them or don't have a tumor at all. So I'll show that here. This MRI scan contains a glaucoma tumor, as you can see by the model's prediction. And based on the explanation, we also get some more insight on the model's prediction. So this is an example of a pituitary tumor. You can see that the orientation of the MRI scan is also different, but the model is still able to classify it with 100% confidence. And you can see here the saliency map highlights a region of the brain just above the sella turcica, suggesting the model is focusing on the pituitary gland. The pituitary tumors are often located in this area, and you can continue reading that there. This is why I think the Gemini 1.5 Flash model or just any multimodal LLM is very helpful to provide more context and insight for this project. So now this is an example of a brain MRI scan that has no tumor in it, and we can see that it predicted no tumor with a confidence of 99.95%. So to summarize, here's the project architecture. We start off with a brain MRI dataset that we will download from Kaggle. Then we will pre-process the images to get them ready to be fed to our neural networks. Then we will construct our models, one using transfer learning and one using our convolutional neural network. This is actually a visualization of the model's architecture. Then We will train and evaluate our models based on their accuracy, and we will display a plot of their training and validation loss, as well as other metrics that are key in training these models. And lastly, we will build a web app that you saw before, where the user can upload an image and the model's prediction is displayed, along with an explanation of the prediction and a saliency map through the Gemini 1.5 Flash model. So overall, this project covers core computer vision techniques through an end-to-end pipeline from data preprocessing to model inference, and it combines it with the latest advancements in multimodal AI with the Gemini 1.5 Flash model. Lastly, I just wanted to mention that this project is inspired by the work I did over 4 years ago when COVID was first spreading, where I built a convolutional neural network that can detect and differentiate between instances of COVID-19 and viral pneumonia in chest X-ray images. I wrote a research paper on this that got published in January 2021 and is now cited 28 times around the world. So this is an overview of the second AI project in the Headstarter Accelerator program, and I hope you all enjoyed it and are looking forward to building it.